Chapter 2, Exercise 23. Show that if script B is non-empty, then A union the intersection of script B is equal to the intersection of the set A union X such that X is in script B. That is a mouthful, but this is a pretty straightforward set equality proof, as we've done several times over the course of this book, and there is nothing new that we haven't seen before. So let's get started. Let's do this left side of the inclusion first. Suppose little x, or rather, what should we call you? Yeah, let's call it little x. I'll rename it later if I need to. Is in A union intersection of B. Then we have three cases. Then one, I don't know if you can use either for three things, but I'm going to do it. Then either one, x is in A, two, x is in intersection of B, or three, x is an element of A and x is an element of the intersection of B. Let's do each one in turn. All right. If little x is in big A, I guess we don't have to call it anything, or rather, we don't have to call it big A, but if x is in A, sorry, I'm just going insane. Okay. Then for all x in big X in script B, and let me just make this more scripty. I feel like I didn't do anything, but but anywho, I hope it helps you. Clearly, these are the same thing. My handwriting is perfect. Then for all big X in B, script B, little x is going to be in A union X. Yes, because if X is already in A, then you really don't have to do much to show that it is in uh, the union of X. Sorry, I'll just write it because for all big X in B, A is a subset of A union X. There, that's the right justification. Never mind my rambling. Okay, so for okay, how do I phrase this? I think half the difficulty of math is not having the right idea, because you see, I know what I want to do. I just don't know how to explain it. And that's why we're doing these videos, so I can learn how to explain my proofs better. Okay, so let's for any element A union X in the set A union X such that X is in script B, little x is in A union X. I don't know if I like that. Okay, let's do this for clarity. Let big S equal the set we're working with, A union X such that X is in script B. So any S in S is of the form little s equals A union X for some big X in script B. Okay, cool. So what I'm saying now is that since little x is in A union x for any x in script B, then little x is in little s for any little s in big S. Thus, for all little s and big S, x is an S. I'm just reiterating, but sometimes I think it's best to do that just for just to double check, just to make sure you're making forward progress. Those for all little s in big S, little x is in little s, meaning that x has to be in the intersection of big S, which is equivalent to saying that x is in the intersection of A union x such that x is in script B. Okay, so there we go. That's case one. Now, case two is x is in the intersection of script B. So since little x is in the intersection of script B, for all big X in script B, little x, it has to be an x. So for all x in script B, okay, let me rewrite that. We also know that for all big X in script B, big X is a subset of A union X. That is just, I think that should be pretty clear by now. Because if you union a set with anything, then the set you union with has to be a subset of the bigger union. Anywho, I'm digressing. So, so what now? So for any little s in big S, or for clarity, call that S in S is of the form little s is equal to A union X for some big X in script B. So for any little s in big S, little s is equal to A union X, meaning that little x is in small s with little s. I think I skipped a little step. It might you might have caught it, but and it's also not that important, but I think it's useful. We also know that thus for all x in script B, little x is in A union big X. I think this was the key step I was missing. All right, so there we go. So just to recap, because this has been a pretty messy part, we assume that X is in the intersection of B. So since X is in the intersection of B, then it has to be in every element of script B, or B. Let's just call it B. So you pick out any X, any X in B, and X, little x has to be in that big X you picked out. Now, we also know that if you union X with anything, then X is going to be a subset. So this X has to be a subset specifically of A union X, right? And this applies to every single X in B. So for all X in B, for all big X in B, X has to be in A union X because it was here originally. So it has to be here as well. I hope that's clear so far. Then what I did was just reiterate the fact that all the elements of S, which is, sorry, this set right here, never mind that little dot, this set right here, all the elements are of the form S equal A union X for some X and B. So for, oh, why does it say for an? For any, oh, maybe when I added the new page. So for any little s in big S, S is equal to A union X, right? And since we have that little x's in every single one of these big X's, then X has to be in this little s. Okay, I think the G and the Y got dragged out. Let me just double check. Yeah, here they are. Okay. Cool. Right. So what does this tell us? This tells us that X being an intersection of B implies that X is in S. Hold up. Sorry, no. Okay. What I was trying to say is that for all S, for all little s in big S, little x is an S. Sorry, little s, which is equivalent to saying that X is in the intersection of S. Thus, little x is in the intersection of the set A union X such that X is in script B. And thus, intersection of B. Yeah. X being in the intersection of B implies that X is in A union X such that X is in B. 1 second. Yeah. Okay, I think we can leave it at this. And then 3, if X is in A and X is in the intersection of B, then both 1 and 2 apply. So regardless of choice of little x has to be in the intersection, of A union X such that X is in B, meaning that A union the intersection of B is a subset of A union X such that X is in script B. Okay, cool. So, yeah, I'm sorry that this proof got me tripped up a lot more than I thought it would. I hope it was clear. I'll do a recap at the end. So if you didn't get it right now, we'll go over it towards the end again in a more linear fashion. Okay, now for the other side of the inclusion. Suppose little x is in this set A union X such that X is in B, right? Sorry. Almost made the same mistake because I did when I was solving it earlier. Intersection. I don't know why I keep forgetting to write the intersection. All right, yes. Cool. Then what do we know? Then for any little s in this set, A union X such that X is in B, little x is in little s, right? So for all for all little sorry. Let's see. How do we phrase this? For any big X in B, little x is in A union X. Since little x is in the intersection of the aforementioned set, so for all x in B, x is in I'm just rewriting what I wrote up here. Okay. Okay, so how do we write this? You know what? I am gonna rewrite it. So rewriting in a more formal language for all x in B, little x is in A union X. Now, there's, as usual, three major cases to cover. That x is in A. Two, that for all x in B, x is in X. And three, x in A, and for all x in B, little x is in big X. And as usual, the third case is just the combination of the first two cases. As you can see, so case one, if x is in A, then immediately x is in A union anything, so we can just pick it's in A union the intersection of B. So yeah, that's pretty, we're cheesing math right now. Now, if for all x in B, little x is in big X, then x is in the intersection of B. Which means that x is in A union the intersection of B. And then 3, both 1 and 2 apply. So little x is in A union the intersection of B. And then this tells us that little x is in, that this set is a subset of A union the intersection of B. We can finally conclude that A union the intersection of B is equal to A union X such that X is in B. Okay, now, due to the fact that I kind of skipped around on this proof, let's just go over it in order from the beginning. Right, so we're going to prove first that we're doing it on, we're going to show that this is a subset of this, okay, this way, and we're also going to prove it this way, and then we should have our equality. So, proving it that way, we have to suppose that little x is an A union the intersection of B. So this splits up into 3 cases, right? Because there's 3 cases under which x is an A union the intersection of B. The first one is that x is an A. And if x is an A, then you can just pick any x in big X in B. And since A is a subset of A unioned with anything, then little x is going to be an A union X. So that's one way to show that. That's one case down. And then what we did was rename S to this, or rather, rename this set to a more simple letter to work with. And we made the argument that any element of big S, which we called little s, has to be of the form A union X for some X, big X in B. Right? So what we said was, since X is in A union X for any big X in B, then if you pick out any little s from the set big S, then X has to be in that little s. So rewriting it in the more formal language, for all little s and big S, X is in little s, meaning that X is in the intersection of big S, which tells us that X is in the intersection of A union X such that X is in B. A mouthful. again. All right, the second case was x being in the intersection of b. And what that tells us is that if you pick out any big X in B, then little x has to be in that big X. And making a similar argument to what we did for A, if you pick out any big X in B, then that big X is a subset of A union big X. Because, yeah, the usual reason that any set is a subset of itself union with something else. So, if you pick out any big X in B, X is in A union that big X. And then what we said was if you pick out any S, little s, from the big S set, then that little s has a form A union X, right? And since we showed that for every single one of these X, big X, little x has to be an A union X, then little x has to be in any S because they're the same. Little s is the same as A union X. So, for all little s in big S, x is in little s, which is the exact same thing as saying that little x is in the intersection of big S. And then all we wrote down was an expansion of what this set is. So x is in the intersection of A union big X such that big X is in B. Right. And then this, pretty simple. You just argue that if 1 and 2 apply, then 3 certainly has to apply. And then our final conclusion is that no matter which case applies to your little x has to be in this set. And this is just the same thing as saying that A union the intersection of B is a subset of the intersection of this big set. Okay, now we're moving on to the other part, the other side of the inclusion. So now we're instead supposing that our little x lies in the intersection of A union X such that X is in B. So if you pick out any S in, I don't know why I didn't call it big S, but anywho, pick out any little s in this here set, then little x has to be in that little x. So for any big X in B, X is in A union X. Because little s and A union X are just a different way of writing the same thing. So then I just rewrote it, saying that for all X in B, little x is in A union X. And this splits into a couple different cases. The first is if X is in A, then immediately you can just say that X is in A union the intersection of B. You don't have to do much. And then the second case is that you use the fact that for all big X in B, X is in A union X. So if that is the case, then X has to be in the intersection of B because little x is in every big X in B. So once you have this fact, then you can just union it with A, and then X is part of that set. Then 3 is just applying 1 and 2 combined, and you have that little x has to be in that set as well. This tells us that this set is a subset of that set, and then finally we can just conclude that these two sets must be equal since they are subsets of each other. I feel like even the recap was pretty bad, but let me know if there's anything that wasn't clear from the video or anything I should expand on. If it's that incomprehensible to everyone, I'll just redo the whole thing and then upload it later. Probably after I'm done with all the other exercises. I think these videos are mostly meant just one as a little guide for me or anyone who wants to get an idea of how to solve these in case they need a reference, and 2 as a small guidance on how you can prove these exercises, these theorems. You don't have to follow what I do. You don't have to write the same proof. But my idea when making these videos is that if someone is completely stuck and they can get like just tiny bit of guidance on what to do, maybe look at the whole thing, maybe look at just part of it, and then solve the exercise on their own. So this is me just saying that even if you watch this video, I encourage you to do the whole thing on your own, preferably without me talking. Even if you watch the video and you feel like you understood the answer, just try writing it out. And you'll find that these are challenging even if you know what to do. I mean, right next to me, I have my notes on how I solve this. Granted, they are pretty messy. I just kind of write down the sketch of the proof, or I write out the proof, but I cross out stuff that I don't like. And then I try to do it without looking at my notebook too much. And this is why you get these messy ass videos. But I am talking too much at this point. Regardless, if this was helpful, then I'm happy. If it wasn't, let me know how I can make it better. And with that said, I will see you in the next video. Bye bye.